So in this question, we're going to be looking at a common household hazard. So uranium naturally occurs in many parts of the world, including Canada, as uranium-238. That's the common isotope of uranium. As that uranium isotope decays over long periods of time, one of the products is radon. And radon is itself radioactive and is hazardous. And so over time, these deposits of radon created by this naturally occurring uranium can seep into homes, primarily through the basement. So what I have here is I found a nice infographic about radon entering the home from Global News, and it's showing you here that we have kind of radon coming in largely through cracks in the walls or through different utilities, through your sump pump and these kinds of things. So there's lots of different ways that radon can get into the basement. If it's a very small amount, that's probably not too dangerous, but it is something that homeowners should check. And if there is too much radon, then it needs to be dealt with because it can cause and does cause lung cancer. And so there's a threshold where if you're past this amount of activity from radon, you need to come up with a system that pumps fresh air in and replaces that more dangerous radioactive air. It's surprising and not good. So what we're told in this question is, well, let's look at that situation. So we're told that the radon-222 decays by emitting an alpha particle, which is a helium nucleus, and it's a 5.5 mega electron alpha particle. And this process has a half-life of just under 4 days. So radon is a gas and it gets into your basement, and what they're saying here is that a recommended threshold for activity is about 4 picocuries per liter of air. Pico is a factor of 10 to the negative 12. Now what it's asking us to do is consider, well, how many radon atoms are there in 1 cubic meter of air if the activity reaches this threshold? So how much of this radon does it take to reach this dangerous threshold? Okay, well, this question is going to take a few different parts, and part of it is going to be unit conversions. But let's back up a moment and remind ourselves what activity is. So activity, or big R, is this rate of change. It's how many decays are happening per second. So you can imagine that something is very radioactive. It's going to have a high rate of change here. There's going to be a lot of decays every second, and that's more dangerous. And so this R is equal to our rate times our number. Okay, so what we actually want is N. Okay, that's not so bad. It's R over little r. And neither of those values are in the units we want them to be in. Okay, so the R value, the activity, well, we're going to be able to get that from the activity we've been provided, but they've given us activity in terms of picocuries. Well, that's an older unit, and we want to convert that to becquerels, which is our SI unit. In addition, they've given us the activity per liter of air, and we've been told to find how much in 1 cubic meter of air. So we're going to have to convert those 2 units. Now on the R side, the rate side, we're not given the rate, but we are given the half-life. So let's take a look at that first. So let's do these conversions. The half-life, where shall I do this? I shall do this here. So our half-life is given to us as 3.82 days. Let's put that in terms of seconds. So there's 24 hours in a day, and there's 60 minutes in an hour and 60 seconds in a minute. So we do all of this and we get 330,000 seconds. Okay, that's a good start. What about the R value? Well, we may remember that the half-life is related to tau, our lifetime, times ln 2. So let's say recall. All right, well that we can just say is 1 over r ln 2. And so then we have r is equal to ln 2 over our half-life. All right, so then we can get our r value. So it's ln 2 divided by 330,000 seconds, and that gives us 2.1 times 10 to the negative 6. All right. Just wall that off for organizational purposes. And so let's rewrite what we wanted. So we knew that r is equal to little rn, and we want n, so n is big R over little r, and is equal to, we don't know big R yet. Okay, so 1 meter cubed is going to be equal to 1,000 liters. This is the conversion for units we're going to need, because what we were given was R is equal to 4 picocuries per liter. So we're going to need to convert. First, we can convert to meter cubed. And now let's convert as well to becquerels. So our liters are going to cancel, but then we want to also convert. So we're going to go 3.7 times 10 to the 10 becquerels in 1 curie. And now we're able to get an activity 148 becquerels. And that is in a meter cubed. Now we're good to go. So now we can say, well, 148 becquerels in a meter cubed divided by 2.1 times 10 to the negative 6. Okay, so now we get a number. And so we get 7.05 times 10 to the 7, and that is atoms. All right, so this question relied on knowing what activity was and primarily moving the information that we were given into units that we could properly use to get what we wanted. Because that's it. Stay away from radon.